Okay, welcome back to continue chapter 1, this time with the sub-chapter 2, which is about network topologies. The term topology refers to the map of your network, the map and the design of your network. How many devices, what type are these devices, how are they connected together? The entire map of your devices, of your network, with all its information or physical information, is called topology. So topologies represents the maps of our networks. There is a lot of type of topologies that depends on the way that you design and you connect your devices together. First type, which is mentioned by Cisco in this course, is the 2-tier and the 3-tier topologies. The 3-tier came first. That answers the first question, which one came first. The 3-tier topology design came before the 2-tier. These two types are typical for enterprise and campus networks. Enterprise is a term for a small company. If you have a small company, like we say from 20 to 500 employees, this is called an enterprise company. Campus networks even smaller than mid companies, like small to medium size companies. Okay, both types of companies, of these companies, can make a good use from both either 2-tier or 3-tier design topology for their networks. Which one came first? We just answered it, is the 3-tier topology. And what's the difference? Mainly you can see the difference from these two topologies. This is the term topology. As if you have watched the previous lectures, this is called a router. This is a multi-layer switch. This is a switch. These are end devices, which is servers and PCs. So this is a topology because these are my devices, my network devices, and these how they are connected. You can see my router is connected directly to my multi-layer switch, and this switch that I have is connected to this multi-layer switch, to the other multi-layer switch, and also it's connected to the server. So my devices, my connections declared together, and my design, all of this under what's called a topology. Okay, so the first type, which was released, as we said, the 3-tier came first. Okay, the 3-tier consists of 3 parts. Each one is called tier or 3 layers. The first layer that I am concerned about, because I am an end user, I am a computer and a device, but I'm concerned about the first layer that I face is the access layer. This one. This is the access layer. That is the first layer I face in my network. Okay, so these devices firstly will start with the access layer. This layer mainly is a layer 2. The access are layer 2. What are layer 2? We just mentioned that switches are layer 2 devices in previous lectures. So these devices mainly have layer 2 devices, which are the switches in the access layer, and connected directly for the second layer, which is called distribution. As you can see, devices are getting lesser. So 10 up to like 48 PC can be connected to a single switch. Multiple switches are connected, can be connected to a single aggregation, and it's not clear in this topology, but you can connect multiple distribution devices to a single core. So it's like a tree. It's like branches of tree. The more that you go out or away from the core layer, the more devices and branches are generating, and you have even more of them. Okay, so more than a single end device can be connected to a single access device. More than a single access device can be connected to a single aggregation device. Distribution, which is also called aggregation. Yes, I have recorded this in here. Okay, and more than distribution device can be connected directly to a core device. So we have the three layers, which are called the three tiers. Okay, that's a mess. Okay, the three tiers. The first one is the access, which its operation or its function is to connect me directly to the distribution, and another function for the access layer is the authentication. It authenticates me, it authenticates my specifications, whether it's allowed to enter the network and go beyond the access layer or not. If it is, then the access layer will direct me to the distribution layer. Distribution layer are very fast and expensive devices, mainly are multi-layer switches or routers, which is in both cases they are a layer 3 devices. The function of the distribution layer is fast convergence, because the authentication happens at the access layer. So since I'm authenticated, there is no other need or no other reason for me to get more delay. So directly from the distribution layer to the core layer. In the core layer, we mainly have routers, we mainly have huge powerful routers, just like we saw in the previous lectures. If you have the slides or if you have watched the previous lectures, you see that there are routers that starts from a single rack unit up to a half rack in the size. These are the huge and powerful super routers. Okay, so this is how we can connect. As well as you can see, the other important thing about this topology is redundancy, because this switch is connected to both distribution devices. In case a failure happened in one of them, we will not lose our service. We will not have some term called outage. Outage is where you lose service, is where you are unable anymore to get to the internet or across beyond the network, your network. Okay, this is outage. So this access switch that I am connected to is connected to it's connected to distribution devices in case a failure happened. That's first, and even these should be connected to routers, but that depends on your design. This is called redundancy. This is the first type of two types of 2-tier and 3-tier topologies. The second one is simpler and came after the 3-tier. It's called the 2-tier topology. In the 2-tier topology, we have like the access, the layer 2, and after that a new term for the distribution is called the aggregation tier. This one. Aggregation, nowadays we can call it even on the distribution, no problem. Distribution and aggregation are of the same tier, but with simple differences. Okay, in this type of topology you have only access and aggregation, no core. This depends on your network, its size, the number of devices, and how do you want to manage it or design your network. This one for this. Okay, next we have another type of design which is called spine and leaf. The spine and leaf. This type of design is especially for data centers. This type of design is applied inside a data center, okay, using special protocols and special type of devices that is called nexus. The nexus switches. This is a series of Cisco switches. It uses a special version of operating system, unlike the normal operating system that we are about to talk to in the end of this chapter. The Nexus switches are very expensive, powerful and fast switches produced by Cisco and are used mostly, maybe all of time inside a data center. Okay, so you can apply the topology design of spine and leaf upon Nexus switches inside a data center. Okay, what it's asked for are two things you should be sure of when using spine and leaf with Nexus switches. First one is full redundancy. As you can see here, this switch of the leaf is connected to both of them. Each switch of the leaf is connected to all the switches of the spine. Okay, this is the spine, like the aggregation. It has the multi-layer switches of the Nexus, and the leaf also using Nexus switches, but this one will go to the servers. Mainly it will not go to end devices like PCs, but it will go to servers. We did use the term and device to servers also, but no problem. Okay, so mainly this will be connected to servers. Servers will be connected to the leaf, which has more than a single connection to the spine, so they don't lose it. And the spine will go back then to the core, of course, because the core is what connects you to the internet. Full redundancy, we talked about it. No outage is allowed inside a data center. No outage is allowed using the Nexus platform switches. They are super fast, super powerful. They need special cooling and moisture specifications inside the room of the data center, so they will function properly without any outage, without any problems in CPU, RAM, other specs. Everything should be fine always. Okay, this is the second type. After that, we will go to the third type, which we have talked about in the beginning of chapter 1, which is wide area networks, or WANs, which is connecting more than a single network but throughout the internet, because each network of them is for a single separated company. Okay, and wide area networks, it can be on three types. Which types you will prefer or you will find in your network? The first one will be point-to-point, is connecting this company to this company. Of course, you can see it's a router because in the end the core layer contains routers. Okay, connecting two different companies through the internet privately. Don't forget, you don't want the internet to see your informations or to know what you and the other company talking about. Okay, so through the internet. And the cloud here not just represents the internet, it represents the WAN itself, because inside this cloud there might be a lot of other companies, because they are in the middle of the way connecting me to the other company. That may be because of how the companies are designed in your governorate country, or it might be because of the geographical spot. Maybe each one of these companies in a different country or in a different continent. That depends on the geographical spot that your company and the other company is in. Point-to-point means that you both should, using some technologies and some protocols, connect each other together in a way that these two routers thinks that they have like a direct cable between them. This is something about WAN protocols that you will study in further courses. Okay. The second type is called broadcast domain networks, and also called Metro E, and E here stands for Ethernet. Metro Ethernet, the shortcut for it is Metro E. This one happens this way. All these are companies connected directly together using a broadcast domain between them. And by the term broadcast, I mean that there is a shared median between these companies that allows them to get connected directly together before even connected to the cloud or to the internet. That also depends on how these networks are close to each other and how can they connect themselves together. The third type is called non-broadcast, so there is nothing shared before the router. Non-broadcast multi-access, the shortcut for this is the NBMA, which is now we can use some old protocols or some new protocols like frame relay or ATM with some special devices to connect together, okay, through the internet and through the cloud. This is also a cloud, okay, to connect some companies together without broadcast disruption, just like the point-to-point type. These are the three types of the WAN design or the WAN topology. Next, we have one of the smallest and simplest. We might talk about some small topologies which are called small office, home office. Actually, this is two types of networks or two types of topologies. It's not a real big topology because, just like I said a minute ago, two terms that reflects two network types, because this is a type, this is another type. Okay, the first one, the home office or the small office, can make use of a single router or a single switch to have a network. like this one. This is a small office or a small branch of a bank, small branch of a company, like a small sales department in a mall or in any place that only needs internet and a back connectivity to the main office, connected to a switch, and that switch is connected to 2, 3, maybe 5 employees, and that's it. And that is what called a small office. So a small office is a branch of company. Okay, the other type is home office. It's where you, maybe now or in the future, will have the chance or you will need to work from your home. Okay, you can work from your home, you can have the same environment, okay, like the environment of the company or your office in the company, but from your home to work remotely. All you will need is that your PC connected to a router, your home router, okay, which will take you back to the company's main router, okay, and there is something private that should be established between them. Let's see if it's in the course material, so we will talk about it next in the upcoming chapters, so that it will take you inside the environment of the company to work just like you are working from your company. This is called the home office, the second type. Okay, so home office is like working from home, that's it, nothing complicated about it. Clear. Okay, next, what's called, this is a new type of networks, and it's growing in the market these days and becoming really important. This is on-premises versus cloud-based networks. This is a type of network against the other type. All the types of networks that I was talking about since the start of topologies until now is an on-premise network. So the first question, what's the difference? We will talk about the difference. And which one is the classic known network? Well, it's the on-premise. On-premises means that all your routers, switches, firewalls, if you remember them, IPS, servers, all of them are inside your company or inside your data center, which is in your main branch, main company, okay, main office. This is what the word or the term on-premise or on-premises reflects to. Having all your own devices that you own them inside your own location, in your own company. So everything is in the office or in the company or in data center, etc. It depends. Or what's important is that they are inside your territory, your place, because they belong to you. This thing have some concerns, this type of networks have some concerns, which is that you have to take care of all these devices. You have to provide the exact appropriate temperature and moisture for these devices to work. You have to take care of electricity providing, main, backup, or whatever design you should provide to your electricity generator or providing, okay? You should have the concern and you are responsible for everything of these devices for them to operate and function correctly with no outage. This is for the on-premises. The cloud-based are a new type of network. Just like it's written in here, everything is at the, who are those? At the cloud company, which results in no headache for you or for your local engineers inside your branch office. Cloud companies are new companies establishing, all companies, but establishing this new feature, the cloud or networks or the cloud company inside them, which is that you can purchase and you can sign with them an entire data center, from small data center to big data centers, depending on the number of devices, type of them, the way they are managed and cabled and they're designed together. But it's inside the data center of this cloud company, not inside your company. Okay, so they are remotely your devices. Yes, you have purchased, you have bought them, All of them are your devices with all their types, and you are the one who decides every single detailed feature of them, all the design, the topology, the cables, how you distribute them, how you maintain resiliency or redundancy, all of these. But they are not kept inside your data center or company. It's provided, or it's kept inside the cloud company. With this cloud company, provide to you the responsibility to keep all these devices and to provide to all these devices what's necessary for the device to operate and work, which is what we have just mentioned before: the temperature, moisture, power, voltage, all these circumstances, these typical circumstances, because there will be offers from different companies. We offer you such circumstances for all your devices under such price per year. All what you have is to purchase, and we will give you a management graphic user interface that you can remotely manage your entire network from a single PC that you have, and all of your network will be inside this cloud company data center. So you'll have no headache, you will have no concern about how to keep these devices clean, working properly, have the correct temperature or moisture or power or whatever. This will be the responsibility of another company. All what you have to do is just to sign in, get into inside or in your GUI interface window, and operate your network in whatever method or function that you would like to do. So this is the main difference between the on-premises and the cloud-based networks, okay, which is starting to be applied recently in the markets. What we will study all this course is about the on-premises networks, because we will imagine that we have the network like inside our office. We will build our network routers, switches, and devices by ourselves, but it's not that different than cloud-based networks, because no new technology between them is different. Only this one is much easier in management because it's all supports GUI. Okay, so this is the difference between on-premises and cloud. Let's see if we have any other part. Network architecture models. This will be for the upcoming chapter. Thank you for watching.